Remember when you want to figure out if a number is rational or irrational, you first need to look at if you can simplify your square root. So here we've got the square root of 25. If you need to use a calculator, okay, go ahead and do so. So I know that the square root of 25 is 5. So I'm just going to simplify this. So 5/4, well, 5/4 is a rational number. So it's a fraction. You could also rewrite it as a decimal. As a decimal, it'd be 1.25. So looking at that, it would be a rational number. So make sure that you guys look at your square roots, and if you need to simplify them, go ahead and do that. If you can't, then you know it's going to be an irrational number. Remember, when simplifying, there are two different ways that you can simplify. You can use the factor tree, which I'll do first here. So factor tree, I'm going to simplify 240. So I know that 2 goes into 240, goes in 120 times. Keep simplifying, so 2 times 60 gives me 120. 2 times 30 gives me 60. 3 times 10, and then 2 times 5. Remember that your factor tree can look different as long as you have the same factors. So my factors here, I've got 2 times 2 times 2 times 2 times 3 times 5. And if you need to circle these as you're going through, go ahead and do so. I like to circle them just so I can keep track of all of them. Remember that pairs come out, so I've got a pair of 2's and another pair of 2's. So remember that they come out, so I've got 2 times 2 on the outside, and then 3 times 5 stuck in there. Multiply both, so I've got 4 square root 15. So that's one way you can do it. The other way is your perfect squares. And you should end up with the same answer either way. So perfect squares, we're going to take this 240, so the square root of 240, we're going to see what perfect square goes into it. So remember, start at the top of your list. So I'm going to do 240 divided by 100, doesn't come out perfect. 240 divided by 81, still a decimal. 240 divided by 64, still a decimal. 240 divided by 49, still a decimal. 240 divided by 36, still not working. 240 divided by 25, nope. 240 divided by 16, ooh, that one actually works. So 16 times 15 gives me 240. Remember that you're going to take the square root of 16. If you need to separate these, go for it. So the square root of 16 is 4, and then 15 doesn't simplify anymore, so 4 square root 15. Notice that we got the same answer either way using the factor trees or perfect squares. All right, we've got 2 square root 54 plus 5 square root 24. So first we want to simplify inside of our radicals, see if we can, and then see if we can add. Remember, you can only add or subtract radicals when they have the same number underneath the radical. All right, so I'm going to look at my 2 square root 54. I'm going to do the perfect square method. 16 doesn't go into it. 9 does, though. So 2 square root 9 times 6 is 54. So the square root of 9, I'm just going to rewrite this. So square root of 9 times square root of 6. Square root of 9 gives me 3. So I've got 2 times 3, square root of 6, which then gives me 6 square root of 6. All right, I'm going to see if I can simplify my 5 square root of 24 right here. So once again, I'm going to use perfect squares. I know that 4 goes into 24. So 4 times 6. I'm going to separate those out again. So square root of 4 times square root of 6 here. Well, the square root of 4 is 2. So I've got 5 times 2, square root of 6, which then gives me 10 square root of 6. Notice that we've got square root of 6 right here and square root of 6 right here. So now we can actually add these together. Remember, whenever you add radicals, you only add the outside. So I'm going to go 6 plus 10 gives me 16, and then square root 6. So don't add the insides. The insides stay as they are, only add the outsides. All right, so what numbers can you multiply by square root 7 to get a rational number? Well, I know that the square root of 7 is not rational. Okay, so I need to multiply it by certain numbers to get it to be a rational number. Well, first off, I know that anything times 0 is 0. So if I times it by 0, 0 is a rational number, so that works. I know if I times it by itself, so if I go square root of 7 times square root of 7, that's going to give me the square root of 49, which we know that the square root of 49 is then 7. So 7 is also a rational number, so square root of 7 works. And then my last one is, I know if I multiply it by the negative square root of 7, notice that the negative's on the outside. Okay, you can't take the square root of a negative number, so the negative's on the outside. This is going to give me negative square root 49, which then will give me a negative 7, which is also a rational number. So my answers are going to be this 0 right here, because anything times 0 is 0. If I times the radical by itself, and if I times the radical by the negative of itself, so like negative square root of 7. So all of these will give me a rational number. Properties of exponents, make sure you guys have that chart that I created a video on in the announcements. Make sure you have that all filled out to keep track of all the different properties. There's lots of different things going on with them, so we're going to go over a couple problems with those. So here I've got x to the 6th divided by x squared, and that's all to the 5th power. So remember that this 5th power right here, it's going to distribute to our 6 and also our 2 on the bottom. Okay, so what I mean by distribute is it's going to be multiplying. So power of a power means that it's going to be multiplying. So I'll have x to the 6 times 5, and then x to the 2 times 5. All right, well that gives me x to the 30th over x to the 10th. And then I can use quotient of powers because my x's are the same base, so they're the same variable. So because of that, I can actually subtract my exponents. So I'll still have my x, and then I'll go 30 minus 10, which then gives me x to the 20th power. And that's as simplified as I can go. There's another way you could solve this if you realize that it was quotient of a power first. So like x to the 6th, and I'll rewrite it over here in a different color. So realize that you can subtract these first. So you could have x to the 6 minus 2 all to the 5th power. You'd have x to the 4th to the 5th power, which would then still give you x to the 20th. So there's multiple ways you could solve this. Okay, whichever way works for you, go for it. And we're going to go over one more like this one. So we're going to look at another one. It's going to be a little bit more complicated though. So notice once again that I've got this 5 out here. Okay, so I'm going to use the power of a power. So that means that it distributes to every single thing inside of the parentheses. So I'll have 2 to the 5th power, c to the 3rd times 5, d to the 5 times 5 on the top. Then I'll have 5 to the 5th power, and then c to the 2nd power times 5. So notice that all of these are timesing by 5, exponent-wise. The 2 is also, there's like an invisible 1 right here. Also with the 5, there's an invisible 1. So that's why we can put that as the 5. So it's really just doing 1 times 5 right there. So 2 to the 5th power gives me 32. And then I'll have c to the 15th, because 3 times 5. I'll have d to the 25th. And then 5 to the 5th power, gotta grab my calculator for that one, is 3,125. And then c to the 10th. Well, I notice that I've got a c on top and a c on bottom, so that means that I can use the quotient of a power just like our last problem. So I'll have 32 over 3,125, and then I'll have c to the 5th, because if I go 15 minus 10, that gives me my 5 right there, and then d to the 25th. If you can, Try to simplify the 32 divided by 3,125. If it comes out as a whole number, awesome. If it's a fraction or a decimal, though, just leave it. If you can simplify it to be like a simpler fraction, go for it. I don't think that this one does, though. So I'm just going to leave this like that. Okay, so if you have numbers out front, try to simplify them. Simplify the fraction. If it gives you a whole number, go ahead and do that. With our compounded interest, make sure that you guys have the formula. So our formula is A equals P times 1 plus R divided by N to the NT. And I'm going to describe what all of these are first. So A is going to be your total. P is your principal, and this is your starting amount. R is your rate, but make sure you change it into a decimal. So I'll give it to you as a percentage usually. Make sure you change it to a decimal. N is the number of times it's being compounded. And then T is your time. All right, so I'm just going to go through and I'm going to label all of the things that I know. So I don't know A because that's going to be my total. I do know the principal though. The principal is my starting amount. That is the 25,000 in my problem. My rate is that 3%, which is going to be 0.03. So to change from percentages to decimals, make sure you divide by 100. N is going to be 4 because it's compounded quarterly. So quarterly means that it's compounded 4 times. And then T is going to be 8 because my 8 years right here. So then I'm just going to plug everything into my formula. So I'll have A equals 25,000 times 1 plus my rate of 0.03 divided by 4, and then to the 4 times 8. Plug that into my calculator. And once you plug that into a calculator, I got that my total would be $31,752.78. Okay, so make sure you have all of our things down here, especially the formula and what each letter means. And then make sure that you, when you plug it in, and especially when you do it in your calculator, that you have all of this parentheses being raised to the power right there. And if you need any help with the calculator, please let your teacher know. Problem here, whenever we are solving our exponential equations, remember that you need to have the same base. Okay, so same base means that you can set the exponents equal to each other. So I know that I need to change this 25. Well, I know that 25 is 5 squared. So I'm going to rewrite that as 5 squared. And then remember that your original exponent goes in parentheses. And then that equals 5 to the x plus 8. Well, my bases are the same, so now I can set the exponents equal to each other. So 2 times the quantity x minus 3 equals x plus 8. And then go ahead and solve for x. So I'm going to distribute my 2 here. So I've got 2x minus 6 equals x plus 8. I'm going to add 6 to both sides. So I've got 2x equals x plus 14. Subtract x from both sides. So then I get x equals 14. You can always plug this back in to check and make sure that it works. So if you wanted to do that, you could go 25 to the 14 minus 3 equals 5 to the 14 plus 8. So that would give me 25 to the 11th and then 5 to the 22nd. And then go ahead and plug that into a calculator. So I've got 25 to the 11th, which gives me a huge number. And then I've got 5 to the 22nd, which gives me that same huge number. So I'm not going to write that number down because it will take way too long. But if you need to, check and make sure that you get the same number after you plug in x. And if you guys have any questions or need any help, please reach out to your teacher. Okay, we are here to help you guys. Good luck on the test. You guys got this.